Hi, my name's Doug, and we're here on the outskirts of Louisville, Kentucky. This is Emerald Hill Skies, and welcome to tonight's live stream. If you are listening, I see we have several already on. If you wouldn't mind telling us how the music sounds in relation to the voice. I don't know if I can try to make it so I can hear it here live, but you know, it's never quite as good when you're trying to monitor your own. Several already on. If you wouldn't mind telling us how. Okay, I'm at least able to hear the voice. I don't know if that music needs to come up a little bit or if you guys think that's okay. Etienne and Stu and Mike, welcome, and let us know if you think that music is about the right volume. You know, you kind of want it in the background, but not so loud that it overwhelms the voice. We're working from a list of targets, again, that you can find down in the description. And the first target we're working on is NGC 5363. And NGC 5363 is located, tonight anyway, over in the western horizon. It's in Virgo, just a little bit above the horizon, kind of down there in that sky glow of Bowling Green and Louisville, Kentucky mixed in there. We do have the camera already going, so this is actually the imaging we've done so far. Let me tune up our image here a little bit. I think we can darken the sky and give us a little bit better contrast with this object. Yeah, that's a little better, isn't it? And then you can see that we've actually got 3 objects at least in view. Dane says, do you wear anything other than polo shirts? That's awesome. Tommy, good to have you on board. We've actually got 3 objects here in view, but this is the object we're observing here tonight, especially with the Herschel 400. It's NGC 5363, and it's classified as a peculiar galaxy. And I can see why. Let's zoom in a little bit more. Now, down here on the lower edge, you can see there is a superimposed star that really has nothing to do with the galaxy, and that gives it a funny look, doesn't it? It's sort of elongated. I'll zoom in a little more with the digital zoom so you can at least see that structure a little better. This superimposed star is not at all part of the galaxy, but the galaxy is a peculiar galaxy. It doesn't have any spiral structure. It's not like a disk like the Milky Way, and it's not barred or even what you might call an elliptical galaxy. This one's just peculiar. We don't exactly understand it. I've been reading about it here in Steve O'Meara's Herschel 400 observing guide. And you know, the Herschel 400 we kind of use as our guide through this list. Steve O'Meara says that this is a moderately small but bright galaxy. It hides in the midsection of a bleak and lonely corridor of space between first magnitude Alpha Virginis, which is Spica, otherwise known as, and 0 magnitude Alpha Boötes, which is Arcturus. And it's a compact globe, making a fine target for small telescope users. From a dark sky, it can be picked up in a sweep. It does say it'll be hard to find. And he says the 12th magnitude star that's superimposed on it is not really a part of the galaxy itself. It's a sharp core and a halo that brightens gradually toward the middle. Extremely sharp star surrounded by a circular inner iris is what it looks like. So this is NGC 5363, and really this target should have been viewed in June. We're just now catching it because of the way we look now. Look over here on the left, and you can see that this is NGC, I just think it's interesting, NGC 5364. NGC 5364, but look at the spiral structure we're starting to see in that little galaxy, and that is not picked up in our planetarium software, interestingly. The planetarium software just kind of shows that galaxy as a glow. You know, there's no real spiral structure that you can see. So our RASA 11 is really doing an okay job. Of course, we do have some time on this target, 25 minutes while we've been waiting for the live stream to be ready. So we're gonna save that exactly as seen, and then in our sequencer, we're gonna go ahead and switch that to next target. Now, you know, we've been working with our sequencer just a little bit, and now we have it set so that that box goes away. That makes it run a little bit faster. We're going to go to live sky, and we've already got the 5363 queued up here. We're going to remove it from the H400, the Herschel 400 working list that we have, and then save it. And then back here in our planetarium software, Starry Night Pro Plus, we're going to add this to the Herschel 400 observed list. Okay, so that's our workflow. We've already done a little observation of this. It's truly a peculiar galaxy, just kind of a blob. And so we've got that already done. We're ready to go to the next target. I'm going to look down here and see what we're missing. When is the supermoon happening? Also, there's a comet or asteroid that's supposed to be visible. Comma, I bet you meant. Yeah, there's usually always a comet, a comet visible, and usually always asteroids visible. The supermoon, I don't know that it really, maybe that's more media hype. The moon is pretty much always the moon. So we're not going to be looking at the moon tonight. It's not even going to be rising while we're viewing. Dane says that object at the left looks really interesting. I know, that spiral galaxy was really cool, wasn't it, Dane? You know, I don't think it is on Herschel's list. I don't think that object at the left is. See, that was 5364. You know, we can check that in the back of the book here and just see. That's actually a good question, Dane. NGC 5364. 53. Oh, it is 5364. It is, and we've already observed it. So, thanks for that question, Dane. That was actually a really good question. Okay, we're ready for the next target, and it's 10:10. So we're just about maybe 4 minutes late already. And 5364 was the next target. How about that? So it is observed now. Let's just raise this by 1, and we're going to add that to her observed list, and we're going to go back here to live sky and look for 5364 and remove that from the working list. How about that, Dane? You were sort of a prophet. That's exactly what we needed to do, is look at that little spiral structure next. So I think everybody saw that. We've already removed the live stacking, so it's gone. 5566 is the next target. 5566. I just realized 5566. And we'll salute to it. There's the scope, the RASA 11. You can read more about our equipment down in the description list. And we're going to show info. Tonight we're catching several objects that we had missed. As I said, that one was actually to have been observed in June in Steve O'Meara's book. But we're just now catching it. So that's why it was so low on the horizon. This object's just a little bit higher. It is at 22 degrees, not much higher. All right, so this is NGC 5566. So let's put that up here in the NGC 5566, and also let's go down in the title bar, NGC 5566, and it's a spiral galaxy in Virgo also. A spiral galaxy in Virgo. All right. So what do you say we drop back to auto here, and we'll do a plate solve as we always do on our first 3 or 4 targets. We've got about 14 on the stream. If you've not yet logged in and told us where you're observing from, we'd love for you to do that. We've got Mike and Stu and Etienne. I remember, Etienne, you're up there in Ottawa, I think. Stu, I know you've been on before. It seems like you're maybe in, what, is it California? I can't remember. Mike, you're up in like somewhere in the Northeast, aren't you? I'm sorry, I forget these. Dane is in Minnesota. Tommy, where are you logging on from, if you don't mind my asking? What would William Herschel say if he saw the technology you had available? Laughing out loud, Dane said. Yeah, I don't know. He had a pretty good telescope for his time, but certainly he would probably wish that he had any better telescope than what he had at the time. It was pretty good for his time, but I think he made like 25 telescopes in his time. let's start the live stacking here. You'll notice that little sequence box now goes away just as soon as it executes. So I've been working on that code a little bit to try to make that a little cleaner. Stu, you're from down in New Zealand, a Kiwi. Good to have you. Lisa, glad to have you on from Indiana. We've also changed our imaging sequence just a little bit in its in the gain setting. We've bumped the gain up to 200 at a recommendation of one of the viewers that we had, and I thought, well, I'll just try that and see how that works to image at 200 instead of the typical 100 where we had been for so long. This is a very tiny object, as you can see here in the middle of the screen. Again, it looks pretty peculiar, doesn't it? That grain that you see, some of that will disappear as time goes by, but that grain is also there because we're imaging at a gain of 200 instead of 100. So that grain is going to show up more at the higher gain setting. It's kind of like in 35mm photography when you increase the, what is it, ISO, the grain in the image continues to increase. John, good to have you from Magdalena, New Mexico, and Birdman Cat Daddy, good to have you from Redwood City, California. Welcome. Let's read something about this. This is NGC 5566, and it's on page 197, 5566. It's a moderately small and bright galaxy about 5 degrees northeast of Tau Virginis. Its core is nicely condensed, makes it a reasonable target, but it's only 2 arc minutes long and has a narrow core. It's oriented northeast to southwest with a bright core and star-like nucleus. At 72 power, it has a bright round core with a sharp star-like center. Otherwise, the disk is an amorphous glow. That's what I would have said, an amorphous glow, which with averted vision looks sharper and more tapered toward the northeast. That would be our upper right. Larger telescopes should reveal its 2 companion galaxies, NGC 5560 to the northwest and NGC 5569 to the northeast. So I can see one, and I think that's probably 5560 right here. Perhaps you can see this spiral starting to show up. But let's hop over to our planetarium software and see if we can see the other galaxy in this view. You know, Starry Night Pro does not play well with windowing. There's that amorphous glow, and here's 5560 to the right. Oh, it's up above it. 5569 is above it, so let's see if we can find that. Boy, I'm not sure. I'm not sure we're seeing my... Oh, maybe it's just starting to come into vision there. Probably not visible in the YouTube stream, but maybe just starting to show up. Anyway, there's that amorphous glow. This is NGC 5566 and 1012 to 1018. So we've got 1 more minute on our schedule. Yeah, I can just barely see a little bitty glow that's coming in there, a little spiral there, and let us know if you guys can see those. Phil Reynolds, hi everybody observing from Cypress, Texas. Good to have you aboard, Phil. Dane, so the difference between you and Herschel is about 200 years. Where do you see astronomy in the year 2220? Oh my goodness. I suppose we'll have spaceships out on Mars by then. We'll have a lot better observing stations. Look at the JWST and what it's observing now. Etienne from Huberdeau, Quebec. Good to have you on board. Well, yeah, I can just barely see that glow coming in. I don't know if you guys can see that, but we will save exactly a scene. And then in our sequencer, we'll switch this to next target. NGC 5566. We'll search for that. 5566. We'll remove it from the working list. Boy, we're knocking these off, aren't we? We'll save that. We'll go back here and we'll add it to the Herschel 400 observed list. And here we'll do a little observation. We'll say this target was pretty amorphous, like a blob, but was fairly bright and somewhat defined. Two other galaxies in view. All right, so that's it. Our next object is 5576, NGC 5576. We'll slew to it and open up we'll center on it and open up the information pane. This is at 20 degrees above the horizon. Again, we're picking up these objects that we had missed earlier. So this is NGC 5576, NG 5576, and this is an elliptical galaxy. An elliptical galaxy. I think also in Virgo, but let's confirm that. Yeah, also in Virgo. Let's go back out to full frame. Okay, it's settled down, so we can now start our, I don't think we have to plate solve here. Should be fairly much in the center. Let's go back to the screen here. Don't forget to look down in the description or show notes where you can learn more about our equipment. This is the ZWO ASI2600MC camera, the monochrome camera that you're looking at right there. It's the thing we use to kind of maintain a connection with the sky. You can see the sky glow above Louisville there in the background, and we're using a RASA 11, a Rowe-Ackermann-Schmidt astrograph, and it's there on a Pier-Tech Adjustable-Height pier in our Pier-Tech Tele-Station 2 observatory. It's a roll-off roof observatory about 200 feet from where I'm sitting inside of my office here at Emerald Hills. The main camera we use is actually here. It's a 2600 ZWO ASI2600MC Pro. It's mounted there on an Octopi-Astro camera adapter, and you can see it's anchored to that glass corrector plate on the front end of the RASA. That's behind the dew shield, the black dew shield that you see there. That monochrome camera that looks at the sky so we can maintain a connection with the sky, that rides on an outrigger equipment plate above the telescope, and it's this red monochrome camera. You can see it's not running through a scope. There are a couple of pieces of equipment here. It's the USB power, the USB distributor, and it's done by Pegasus Astro, and also the Pegasus Astro Micro power box are mounted there on the same Los Mondi equipment plate on top of the RASA 11. At the base, you can see our equipment in a gator rack, and there's the 110 distribution by Triplight on the left. There's Rig Runner DC 12 volt distribution, the next level up above that Triplight, and then there's a little 12 volt power adapter there, and then you see the Icron Raven, the unit we use, the 3124, to transmit all the data between the observatory and here. It translates all the imaging into fiber optic cable and runs it in here to the office so we can operate from inside no matter what the weather. Okay, so let's have a look here. There are a couple of objects visible in this. Let's tune up our screen a little bit, darken that sky a little, and let's get an idea of what we're looking at here. 5576. 5576. Boy, sometimes Starry Night Pro just does not want to come back to the front. So 5576 is an elliptical galaxy in the middle. There is 5577 there. above it. So we're looking for the object kind of in the center of the frame, but a little bit to the left. So this must be this is the galaxy that was above it, and this is the object that we're observing here. And you can see it's elliptical, whereas this one is starting to come in as a spiral. Again, there's not much shape. It's not like a beautiful spiral form, is it? This looks like it might be another galaxy here, doesn't it? Boy, these are tiny objects. Let's see what Stephen James O'Meara says about 5576. This is on page 198. He says it's a small, somewhat dim elliptical galaxy near 5566. It's best seen under dark sky with moderate magnification and averted vision. Remember, averted vision is where you turn your eye away a little bit and look out of the corner of your eye. It appears a little larger and more diffuse than the 5566. It swells into an oval glow oriented west to east. Yep. Core seems to be round, right? It also contains a dim starlight core. How about that? The surrounding halo looks fuzzy and out of round. You know, I wonder, here's what I wonder, is that, beside my pointer there, is that, no, I think that's, let's see if we can use the deep sky image annotation here. Okay, so this is 5576, the object we're viewing. This is 5574 down here. This is 5577, and 5566 is the group we just observed over here. So thank you, Robin Glover, for this image annotation so we can make sure we're looking at. So this is 5576. Okay, looking down here in the live stream, Mike 1i. Aloha. Azray, good to have you aboard from Colorado. Mike, right, elliptical. You are on the ball, Mike. Good job. You know, Virgo is just full of galaxies, isn't it? So here in our observation, we're going to say something like, there are so many galaxies in Virgo, we had to use Sharpcap's deep sky image annotation to make sure we kept them all straight. This is a rather oval, elliptical, that's what elliptical means, isn't it? Somewhat bright in the middle. All of these objects that we're viewing tonight, it's the first time we've ever observed them from here at Emerald Hill Skies, and I assume that for some of you guys, it'll be the first time that you see them as well. So we're kind of exploring together here. And I always tell people I'm an explorer, not a guide. This is the first time I'm seeing these as well. Let's go back to next target. This is 5576. We'll slip up to live sky. We'll look for 5576, and we'll delete that from the working list and save it. We'll go back over to Starry Night Pro, where we will add it to the observed list, and we are ready to go to the next object. We'll go, guess we already backed that off. So we're ready now for 6235. 6235. So we'll slew to it and center on it in the planetarium software. Open up a little pane about it. This is a globular cluster. Now it says we observed it on 8/17. So we're not going to spend much time on these. Somehow we already had observed 6235 and just hadn't made a note about it in our notes. So this is in Ophiuchus. So since we already have an observation, we'll just say here tonight, we looked briefly at this again tonight, and this is a very star-rich part of the sky, 6235. 6235. And down in here in our title, we'll just change this 6235. And this was a globular cluster, wasn't it? A globular cluster and Ophiuchus, something like that. Okay, so as soon as this settles, we won't spend too much time on this one because, as I said, we had actually observed this before on the 17th, so just 1 week ago tonight. Right there it is in the middle. Right there. So we'll just observe it just briefly. As we catch our first images on this, I just want to say thanks to everybody who's with us. There are about 17 on board. If you've not already logged in and let us know where you're observing from, we would love that if you could do that. And if you're watching the recording, thank you for being a part of this. You're seeing this live, if you're here with us on the live stream and or on the recording, you're seeing this just like I'm seeing it. There's really no difference. You're able to observe it just as we are observing it here. That's the magic of electronically assisted astronomy. So here we are. We're at 20 seconds and a gain of 200. And let's just annotate this real quick. So there's the globular cluster right up there, NGC 6235. Boy, it's kind of a loose structure, isn't it? It's set on the 17th. Oh, I wonder if it's just really tiny. Let's see how wide it is. 5 arc minutes. So kind of tiny. Does anybody see it yet? Do you think that's the loose? Maybe it's just up here. Let's kind of take a look at it in the 6235 on 221. Fortunately, we do have a guide with us. 6235. Oh, it's just 2 arc minutes. It's speckled, soft gray pallor. Moderately small and dim. 6235. Perth, Simon, good to have you. Jeff, good to have you on from Concord. Boy, are you guys seeing this yet? We saw it on the 17th, so you would think we would. Maybe we need to tune up our, let's tune up our live stack here. This is our problem. This is a different part of the sky, so we needed to, there we go. Now, isn't that funny? It's like one of those, what is that on Star Trek, I think it is? The cloaking technology that the one alien has, we just brought it in like that. What is that called? One of you guys will know that. 4 stars in a straight line at the top right, that's crazy. Yeah, there are those 4 stars in a straight line, top right. All right, so we'll save this now as seen. Since we'd already observed this, let's make sure that it's added to the observed, and it wasn't, so we had missed it last time. That's why we're here again. And now we'll switch back to next target. Let's make sure that we took it out of the working list too. So 6235, sorry. 6235. It was not removed from this either, so that night I was evidently asleep and had not done our administration properly, and that's why we came back and observed it again. Yeah, hydrogen 3, Courtney says, so pretty. Lisa from, oh, the Romulans, that's right. Thank you, Lisa. That's exactly what we were looking for. That was 6235. Our next is 6451. What would we do without you guys that help us remember things like the Romulans? And the ship is like there's a special name for the ship. Romulan Raptor, I can't remember what it's called. 6235. 6451 is the next target. 6451, so let's salute to it. Center on it, open up the info pane for it. Look at that, there's a rare typo in the info pane, unless I made a typo. Okay, let's stop the slewing, because this is not the right target. How do we abort the slewing? I have a typo there. I put 451, and it needed to be 6451. 6451. Center on that, and open up the info pane for that. As soon as that telescope settles, cloaking device. Bird of prey, that's it, Lisa. The Romulan bird of prey. Thank you so much, Lisa. Okay, looks like the telescope has settled, so now let's slew to the correct object, which is back over the other way. You know, I'm going to open up the door. Here where we are tonight, our air conditioning is out in the section of the building. I almost wish I was outside tonight. I think it would be a lot cooler. I'm starting to sweat a little bit in here. Did we already center on this? 6451. Yeah, we did already. Boy, this is a very rich field as well. Look at the telescope. Look at the weights over on the left now. That's toward the west. So the weights are west. And the telescope is Pier East. And look at it sweep past the, you know, along kind of with the meridian. It's sweeping past, you know, heading almost south, I guess you could say. Heading almost south as it. Okay, I think it's starting to settle down there. This is such a star-rich part of the sky. Take a look at the view at using our planetarium software. This is the Starry Night Pro Plus. Such a beautiful part of the sky, isn't it? So we're looking for that. It's an open cluster, and the nickname is the Tom Thumb cluster. Now you get in too tight in Starry Night Pro, and you lose that image of the night sky that it has. And so we're going to now go over here, and it's already queued up there for us, isn't it? So let's go ahead and just start imaging, because it's already right there. The Tom Thumb cluster. Now, why do you suppose they called it the Tom Thumb cluster? Let's see if we can look that up. I should change our titles before we forget. This is 6451. 6451. And down here in the title is 6451. It's an open cluster. An open cluster in the constellation Scorpius. Scorpius. The constellation Scorpius. Go back up to our, this is actually the live view now. It's a beautiful cluster, but man, look at that night sky. Thousands of stars there. It's just so rich, isn't it? Tom Thumb cluster. That's 100%, so let's leave it there for a minute. Let's do a color balance here, since we're in a different part of the sky, right in the Milky Way. And we'll move it over right about there. We don't need a lot of, look at all those different colored stars. 6451 is on page 224, so we're jumping forward now. 224, so now we're in objects that we should have viewed in July. 6451. Steve O'Meara writes, it's a small but reasonably bright open star cluster in Scorpius. Nice compact blaze of stars and a rich Milky Way field. Very nice side appearing 5 arc minutes wide. It's a wedge, okay, of well-resolved starlight. At 72 power, the cluster is an irregular assortment of some 80 stars of 12th magnitude and fainter. The core is elongated, and random arms can be seen sprawling into the Milky Way galaxy. Yep, pretty good description. So let's just go here and say 80 stars of 12th magnitude, according to O'Meara, in a very star-rich field. 6451. Let me look back down at what you guys are saying here. A good evening, universe. Fallon, good to have you aboard. Where are you viewing from, Fallon? Stu, no Jen tonight? She'll be sorry to have missed this. Oh, that's very kind of you to say, Stu. Let's hope that Jen checks in before too long. You're right, she's been a real regular, hasn't she? Okay, so let's say this exactly as seen. 6451. Let's switch to our next target and go over here in live sky. Search for 6451. Oh, look at that. NGC 6451. Maybe we already removed that. You know what? I think I do remember the night that I did that by accident, and I remember thinking, boy, that's going to throw me off because we removed that by accident. 6451 was to have started at 10:30. We're a little bit behind. At 10:36, so we're about 4 minutes behind, maybe 5 minutes even. We were supposed to have gone to 6905. So let's make up some time, folks. 6905. Oh, this is a planetary nebula. So let's slew to it and center on it and open up an info pane for it. This is the Blue Flash Nebula. And it's in Delphinus, the dolphin. DELPHINUS. 6905. This is NGC 6905, the Blue Flash Nebula, a planetary nebula in Delphinus. Let's go over to SharpCat. Well, first of all, let's just look and see what we're looking at here. Wow, star rich. It looks like a tiny planetary. This is going to be super tiny. Look at this row of stars here, like maybe 6 stars. And that planetary is right below that group of 6 stars in a little cluster. Look at that. Look at this cluster around it. I don't know if that cluster is identified. It's not. That's sad. It's Starry Night Pro. It's not identified. So it's 6905. Let's go over to SharpCat and change this to 6905. And, you know, let's do plate solve because we did change to a different part of the night sky. Let's make sure our aim is really good since this is such a tiny object. Let's drop back to the full frame. Spent too long finding the cluster in Ophiuchus, but it was worth finally to see it. I think you're right, Stu. I agree with you 100%. Mike, the star I don't know what that thought was, Mike, if you finish your thought there. Okay, so 1 degree off. So we did go to a different part of the sky. I'm so glad we played solved. We would have looked for that for an eon and wouldn't have been able to find it. And because it's so tiny, we would have looked at 1,000 stars, but we would not have been able to find it. You know what? Now I can see it there in the middle. So let's make sure the scope has settled down. I think it has. And let's go to start imaging. I can barely see a ghost of it right there. Mike, the star images look really sharp tonight. That is so nice of you to say. You know, we did spend a lot of time focusing tonight, Mike. We actually ran the focus routine 3 times to make sure it focused. Courtney, have you ever found a star or something that wasn't found before and named it? That's pretty hard, Courtney, because sky surveys have been done for decades by very large telescopes, much larger than ours. Now, there have been people with scopes our size that have discovered asteroids and comets because they'll sweep into our part of the solar system for the first time. I've not discovered something like that on my own. However, I have found things that weren't previously in the planetarium software, and then had to look them up. You know, so the planetarium software is not perfect. It does have most objects, but again, in this case, in this case, there's a cluster, it looks like, behind this planetary nebula, and that cluster doesn't appear to be identified in our Sky Safari Pro Plus, sadly. I brag a lot on Sky Safari Pro. Look at that. Isn't that beautiful? Now that's 100%, so that's our optical. That's what we would see if we just went to the frame of the camera. There's a star called that, and that's the kind of name I'd give them. Zubin-el-Ganubi. Zubin-el-Ganubi. That's awesome. Okay, so let's zoom in on this now with just a little bit with an optical zoom. And what I think you guys can see if you look really close is that little white pinpoint in the middle of that green glob. Let me just use the digital zoom to come in and see a little more structure. There's a little white pinpoint there. And that's the star that's in the middle of this planetary nebula that's providing all the ionization to light up like a neon sign the orb of puffed out material that star ejected when it was probably a red dwarf and it was about to die. It ejected all that material, then it shrunk down and it caught fire again, and it is operating now as a white dwarf, and that green material is being lit up, kind of probably oxygen rich, is being lit up by that white dwarf in the middle. Fascinating stuff, huh? Thanks for answering. There's so many out there, I'm sure they could never all be named. Well, you're right, but they're probably named to like the 18th magnitude. As you can see in our planetarium software, all these stars, well, not all of them, if they're smaller than 18th magnitude, but look at these, all of these have names, Tycho and Hipparchus numbers. It's amazing how many all-sky surveys there are. But this cluster appears not to be named, interestingly. Before we leave this, let's just look real quick and see what Steve O'Meara says about 6905. It's on page 257. Boy, we're booking it through the book now, 257. Now we're in September. This is what we were to observe in September. Commonly known as the Blue Flash Nebula, NGC 6905 is a beautiful planetary in the Delphinus Milky Way near the borders of Vulpecula and Sagitta. Through a small telescope, it looks like a piece of lint trapped in a carpet of stars. Be prepared to make a very slow and careful search to find it. It's a small and somewhat dim planetary nebula. Usually not a problem if such objects are far from the Milky Way, but in this dense field of stars, it's going to be difficult. He says, look for a clustering of 11th magnitude and fainter stars that form a 4-minute wide trapezoid. And he says that's the way you can try to find it. It's incredibly dim, he says. It's the faintest member of a tiny trapezoid. And he says, at 151, the pale puff of light caged in the trapezoid of 3 11th and 12th magnitude suns and one dimmer one. It's hypnotic to try and pull the planetary nebula out of these stars. Of course, he's using a 4-inch scope, and we're using an 11-inch scope. As the eye swims around, the planetary nebula wafts in and out of view like vapors from a moist mouth on a cold day. For this reason, I call 6905 the Caged Spirit Nebula. If you're Steve O'Meara, you can name things whatever you want, and it sticks. In large scopes, amateurs have had success seeing rich hues as well as the 14th magnitude central star. You got to have a 10-inch and larger telescope. Woohoo! Go RASA 11. So you see the trapezoid he's talking about here, and man, this RASA 11 has no trouble at all, by God's grace, seeing this planetary nebula. So let's save it one more time, exactly as seen. And down here, you guys are saying the ZB. Mike, can't type tonight, sorry. Courtney, laugh out loud, nice descriptions. Yeah, they are, aren't they? Okay, so this is 6905. So let's switch to next target. We'll go over here to Live Sky and find 6905. Oh, I bet it's this space here. What? 6905 isn't in here either? What am I doing wrong? Let's cancel out of this and then hit edit again. And let's find 6905. It's not there. So we've already removed it from the working list for some reason. Add it to, that's odd. This beautiful planetary nebula is called the, what was it called? The blue something. And he called it Caged Spirit. But in Blue Flash Nebula. The Blue Flash Nebula, or as Steve O'Meara nicknamed it, the Caged Spirit, because it was inside a trapezoid of 11th magnitude stars. All right, 6905. One more. Oh, that's just a 3-second image, and look, you can even see it in the 3-second time exposure. You can see it briefly. That's amazing. All right, after 6905 is 6940. We started out at, we're a full 10 minutes behind now. 6940. 6940. All right, so we'll slew to it and center on it. Open up a little information pane about it. This is an open cluster in Vulpecula. 6940. 6940 is an open cluster in Vulpecula. An open cluster. Oh yeah. Look at that. It's hard to tell where the cluster starts. There's so many stars in that field, huh? 6940. Yeah, but we're trained right on it here. I tell you what, we don't need to stack this. That's already a beautiful shot. We'll just snapshot it and that'll help us catch up a little bit. Look how beautiful that is. We will read just a speck of what Omira says, 6940 on 255. He says, very bright, very large, very rich open star cluster. I agree. Looks like a dwarf elliptical galaxy in the smallest of telescopes. It's as if it's being pulled apart by a close encounter with the Milky Way. That's possible, isn't it? Highly elliptical body of shimmering lights with many star clumps that give off a rich mottled glow. Okay, we're going to have to stack this to see the rich mottled glow. We can't skip that. Cluster stars are scattered across the field like highly reflective dust particles in a strong and erratic wind. The cluster contains some 170 members of 11th magnitude and fainter stars, projected against a rich Milky Way background, so the view is visually exhausting. Visually exhausting. 170 members of 11th magnitude. Oh my goodness, he's right. 170 members of 11th mag and lesser. I'm going to put in quotation marks, visually exhausting. Omira. Well, it's a beautiful part of the Milky Way. Stu says he's quite poetic, eh? Goes to the moon? You're right, Stu. I do remember that. Azra, it always amazes me that these objects were discovered with the instruments of the day long ago. Yeah, you're right. Jen, you made it. I don't know if you noticed up above, Jen. Somebody said, where's Jen tonight? Stu, it's their patience that amazes me, right? Yeah, there's Stu. Greeting, Jen. Nice to have you aboard, Jen. Yeah, I can see little bits of what I would just call them nebulosity around some of these stars. We're not going to spend a long time here, but it is striking how beautiful this cluster is. Let's back off and look at it in the visually exhausting. Wow. That is just a beautiful projection, isn't it? All right, so we're going to go to next target. And this is 6940. Boy, I hope 6940 is there. It's going to give me a complex if it's not, and it is. 6940, and then we'll go back to the planetarium software and say, add to H400 observed. And our next object is 7008. NGC 7008. Oh, it's a planetary nebula. Slew to it. Center on it. Open up the info screen. Can you guys still hear the music in the background? Jen, tell us if you can hear the music in the background. Is it too loud, too soft? We're trying music tonight for the first time, I think, in our entire history. We've been doing this for a year and a half. Just a shade over a year and a half. And I think this is the first time I've ever tried music. So here we are in a very busy part of the Milky Way still, and it's NGC 7008. It's a planetary in Cygnus, CYG, Cygnus, the swan. This is 7008. 7008, a planetary nebula in Cygnus. We'll go over here now to Sharp Cap and change that title. It's like a 3-ring circus, isn't it? 7008. And we'll start stacking to see this planetary. Jen can hear it. She loves it. Stu, it's just loud enough to be awesome, but not intrusive. Praise God. Thank you, Stu. Courtney, it's perfect and soothing. Nice. Azri, not too loud. Laura, Good to have you aboard, Laura. Welcome. Lisa, hear it, not too loud. You guys are so encouraging. Thanks. In the description, you can see the source of the music. Boy, right there is that planetary. Right there. I mean, immediately we saw it with just 20 seconds. That's a beautiful planetary nebula, isn't it? My goodness, it's so... If we had an emoji, we'd use the one where the head blows up. That is amazing, the way it's just... That all those particles look like they're traveling so fast from that little white star, presumably that little white star in the middle. Let's move our black to right there and make it a little bit more contrasty. And let's bump up the mids, and that'll emphasize the greens. A little bit too much. See how they turned grainy when we emphasize them too much. This is 7008, which is on page 265. And Steve O'Meara says, it's a bright planetary 5-degree, it's in a 5-degree wide dark nebula. How about that? How spooky is that? It's a fine sight, and all telescopes be prepared to make a careful search for it. Boy, we saw it right away in this 11-inch. He says it's kissing a 9th magnitude star to the southeast. See the little 9th magnitude star? It's kissing. Star also has a 10th magnitude companion. Yeah, see the double next to it. Seen at a glance at low power, the nebula and these stars form a very small and fuzzy double. Like M40 and Ursa Major, so your target is easy to sweep over. At 72 power, the planetary nebula comes to life, being a very beautiful object, a dainty skirt of light clinging to its 11th magnitude neighbor. Yeah, a dainty skirt. How about that? So we're going to say it's, quote, a dainty skirt. This is one of those times that a dainty skirt of light kissing its 9th magnitude companion. And then we better give O'Meara credit of that. Let's go back to the live view. So here's the live view through our RASA 11. It's beautiful, isn't it? Birdman says the music is great. Volume level is ideal. Bless you. Laura is like soothing. Lisa, we need to commune with Carl Sagan. Laura, love those poetic descriptions. I know, Laura. Isn't that something? He gets all imaginary on us. Okay, so we save this. So we'll switch our sequencer back to next target. Let's go grab 7008 from the working list and remove it. And save the working list again. Let's add it to the observed list, H400 observed. And the next object is 7044. 7044, slew to it. And this is an open cluster in Cygnus. 7044. An open cluster in Cygnus. Where does the cluster start and where does the stop and where does the Milky Way start? That's just an incredible bunch of, looks like 7044. 7044. Man. guess it's there, isn't it? Hmm. 7044 on page 262 and 263. 7044. A very small, dim, and difficult open cluster. It's 2 degrees southeast of the 4th magnitude Chi Cygni. It'll be extremely difficult to see in a small telescope under light pollution. Dark skies are a must. 23 power is a very small, 3 arc minutes or less, insignificantly faint round puff of gray light. Huh. Doesn't even resolve at 23 power. In 72 power, one roughly 9th magnitude star is most apparent, as are a sprinkling of perhaps a half a dozen suns. The cluster has some 60 members that shine at 15th magnitude, so the stars I saw were most likely clumps of starlight. So this is a difficult cluster. 704. Oh, I think I see it. It just makes a difference, doesn't it, to have an 11-inch scope. See it right there? It's so obvious. Look at that. Now that's too much zoom. It's into the digital zoom, but there is the limit of our optical zoom. Let's pull this over a little, and that'll help us make out some of those dimmer puffs. You know what I see in the middle of it is a cross. And of course, Steve O'Meara didn't see that because he was using a 4-inch scope, courageous soul that he was. But look at this line of stars here, and then look at this line of stars there. It's like a plus sign. So we're going to say here, there's a plus sign in the middle of this 80-star cluster. Azray, I like the Herschel 400 you're doing. I get to see things that I've not seen before. Big thank you, Doug. You're very kind, Azray. Thank you so much. Stu, seems like the more you zoom in, the more everything becomes one big cluster. Lisa, well, my alien friends, I must retire for the evening. I hope you can get some rest, Lisa. Yeah, Laura agrees with you, Azray. Thank you. That's very kind of you, Laura. Stu said goodnight to Lisa. A wonderful journey to be on and a wonderful person to be on a journey with. Thanks, Doug. Stu, that's very kind of you. Thanks for the encouragement. Laura, I just wanted to peek in to see what the cool kids are doing. God bless you all. I'll be back in to lurk soon. All right, Laura, get some rest. Hope you feel better. Let's see, NGC 7044. So we already snapped a picture of this, I think. Let's snap that and go back to next target. This is 7044. 7044. Remove that from the working list and save. Add it to the list of Herschel observed. And 7044. The next is 7062. You're supposed to do that at 11. We're 7 minutes behind. So we did catch back up. 3 minutes. To move much. Were we just doing 7044? Yeah, 7062 is what we're supposed to be on. 7062. There we go. Center on it and show info. This is an open cluster in Cygnus also. 7062, an open cluster in Cygnus. Right there it is, 7062. Look at that, right on it. So we should just be able to snapshot this. But let's look and see what Amir says about it in case there's something 263. Small and somewhat dim open cluster. On the west end of a 10 arc-minute long chain of 10th magnitude stars, yep. It's unresolved in his 4-inch scope at 23 power, but at 72, it's a menagerie of irregularly bright suns scattered across an irregular disk measuring 5 arc-minutes. Cluster has some 85 members at magnitude 10 or fainter. It requires averted vision for him. 85 members of 10th magnitude or less. 85 members. Well, sorry to say, we had to start this over. 85 members of 10th mag or less. Oh, Mira. And anything else we should say about this gang? A real mixture of stars. Now here's a question. Look at this peculiar shape right there. That looks like it's something irregular, doesn't it? Maybe there are 3 stars there? We're not stacking this. I think we should stack this for just a moment. Just because that is an irregular shape. Let's go back to the and zoom in. Maybe it's, you know, I don't see anything marked here. That's way too zoomed in. I think what this might be is just a system of 3 stars in a row. I bet that's what that is. So it's a 3-star system. But at first it looks sort of like a peculiar galaxy or something. This is 7062. Save 7062 observed. Next one is supposed to be 86. 7086. This is an open cluster in the Cygnus. 7086. 7086. 7086. 7086. Right there it is. We've been Pier-Tech, Vito, good to have you aboard. It did look like an arrowhead. You're right, Azrae. That little formation looked like an arrowhead. That's a good description. Vito, glad to have you aboard. 21 of us here. If you haven't logged on where you're from, we'd love to have you do that. This is 7086, and it's on page 265. 7086. It's a moderately large and obvious open cluster. It's relatively dim. It resolves. Its core is patchy, surrounded by an irregular round halo of dim suns. Yeah. Definite wedge-shaped core. I guess so. With a north to south extension of stars, with a vertivision, the cluster sports broad outer arms in a Maltese cross fashion. What's a Maltese cross? Very pretty. The cluster contains 80 stars of 10th magnitude. What's a Maltese cross? Is that like the plus sign? Well, here's that circle, and I guess, oh, I see. This is one of the uprights, and this is the other. That's his Maltese cross. It's like the plus sign we saw a while ago, except this circle is toward the top. So we'll say O'Meara called to our attention a circle of stars, upper right, and a Maltese cross. NGC 7086. 7086. Did we save this? I can't remember. Next target, 7086. Delete. Again, we're deleting these from our working list, so we know how many objects we have left to go, you see. And then we're adding it to a list called Herschel 400 Observed, so we can kind of compare the two back and forth. And that kind of checks ourselves. Okay, that was 7086, wasn't it? Next target is 7128. We were supposed to start that at 1112. Oh, we're just 4 minutes behind. We made up some time. 7128. 7128. And this is an open cluster in Cygnus, as is everything else tonight. 7128. A little bit tighter, I think. Seven, 1, 2, 8. Yeah. Seven, 1, 2, 8. And that's on page 266. It's a small, dim, open cluster. Very small, but also bright and condensed when seen with a vertivision. A tiny 10th magnitude double star lies on the cluster's southeast flank. Seems to swell from that pair like a bubble. Okay. At 72 power, it's a small circular assemblage of suns with a hollow center, the bubble. 70 members, 11.5 magnitude. About a dozen of these can be seen forming a warped C shape. I suppose if the C were to be viewed, to me it looks more like a turtle shell, because there's a line here. So we'll say, reminded us of a turtle shell, and the brighter star is his eyes, and he's holding a stick in his mouth. We should write a book to compete with O'Meara. this is 7128. Delete from the working list and save. Add to the observed list. The next object is 7142. This is an open cluster in Cepheus, the king, Cepheus, 7142. 7142, an open cluster in Cepheus. A little bit larger open cluster. Wow, look at all the clusters in this view. 7142. 7142. Let's go back out to full frame and plate saw real quick. Just to make sure, since there are several clusters in this view. Jen says, I volunteer to edit the book. Yes, Jen. We're in business now. 7142. Boy, it's a beautiful clear night, isn't it? Look at that. Boy, it's a nice airplane flying across the lower part of the sky there, right over Louisville Hum. Beautiful clear night. We were off 1/4 of a degree, so I'm glad we did plate saw. We can make sure that we end up in the right spot. Just wait and make sure that's settled down. And then we'll stack a bit. And while that's stacking, 7142, supposed to start at 1118. We're back on track. 7142 is on page 276. Way over in September now. So we're working ahead of the game now. 7142, moderately large and dim open cluster about 2.5 degrees northwest of 4.5 magnitude Chi Cepheid. Cluster requires a dark sky to see in a small telescope. Very low surface brightness. Any pollution, any light pollution affects your chances of seeing it. In a dark sky with a 4-inch, it's an amorphous ghostly glow that's just visible above the sky background. Dim suns weave in and out of a view across an area 10 arc minutes in extent. At 72 power, the cluster is extremely difficult to observe. With time, about a dozen faint suns can be seen loosely scattered across the field. The brightest ones form a roughly 5 arc minute wide, oval oriented northeast to southwest. Wow. There's some pretty cool things in this view here. Let's go ahead and annotate this. You know, our annotation is just a little bit off. Look how this is describing that. So this is IC5-132 up there. And the open cluster is right here. It's in GC7142. So the annotation is just a little bit off track, but we won't complain. So IC5-132, and this is our cluster we're supposed to be observing. Boy, we see a lot more suns than he did because we have an 11-inch scope instead of 4-inch. he was using his eyes, and we're using a camera with EAA, so we're stacking time exposures. His eyes couldn't do a time exposure, so his eyes couldn't see all these faint stars here. But hats off to him that he wrote the book with a 4-inch scope just to prove that it could be done. We saw zillions of faint suns and a nebula upper left. Let's go back to NGC 7129. NGC 7129, I bet that is. And NGC 7133. So we're looking at 7142. You know, we can tune this up a little bit. Let's do a quick color match and pull the black level to right there, and then pull the mids in just a shade. Look at that nebula now, upper left. It's not cool? It's got a little green nebulosity there around that double star looking formation. Beautiful. But we're supposed to be observing the open cluster. Azray, glad you have a clear night. I'm still waiting to get my RASA 11 up and running. So sorry, Azray. That cloudiness you've had. Jen's asking about his weather. Don, good to have you back. Fashionably late. Azray, no, tonight so far. I'm in Arizona. Not tonight. Good. Okay, so we just saved this, so now we can switch back to next target. And we're going to 7142. Delete that and save it. And then add it to the Herschel 400 observed. Our next target after 7142 is supposed to be 7217. 7217 is a galaxy. Spiral galaxy in Pegasus. (7217), a spiral galaxy in Pegasus. Okay. (7217). I think we should play it soft because I didn't see it there. Don, thanks so much for asking folks to give the stream a thumbs up. That's very kind of you. That does help get it in other people's searches. Jen has. Azray, thanks for the reminder, Don. Thank you, Azray. A drought. Jen, I love spiral galaxies. Azray, we're in a drought, Jen, but the rain this year has helped us. Okay, so there was a correction, about 0.41 degrees, so I'm glad we played solved. And now I think I do see it there in the middle. let the scope settle just a shade. After it moves, you know, it's kind of like wiggling for a minute in a microscopic way. So we let it settle for maybe 10 seconds or so. Start imaging, and this is 7217. 7217 is on page 283. Very small, somewhat condensed galaxy. It's a small, fuzzy star, he says. At the 4-inch 23 power, very small, 1 arc minute. Oh, right there it is in the middle. Stellar in appearance, the star is the galaxy core. With averted vision, you can see a 2 arc minute wide halo. At 72 power, it's difficult to see with direct vision. Becomes more obvious with averted vision. A circular glow with a bright inner core. 7217. So let's do a color balancing down here on the live stack and move this over to about right there. And then let's move our mids in a little more. Look how much more we could see when we bought into more of the sky glow. But then you don't get the dark skies. In SharpCap, you can hold the Shift key down, and these bars let you fine-tune, and that's a little more control. Okay, so that's just 80 seconds. Let's stack that a minute. This is 7217. A little bit of mottling still. Don, it's the least you can do. You're very kind. Stu, parts of my country received 1 meter of rain, 40 inches, in 3 days last week, so you can have some of ours. Jen, are you in Australia? You might be in Australia, or maybe it was New Zealand. Azra, we can use it. Lucky to get any rain. Yeah, New Zealand, close. Yeah. This is 7217. Oh, we already read that, didn't we? So that's with 2 minutes, and we're already seeing a lot of that glow around the outside. Let's save that as scene. This is NGC 7217. Remove. Save. Oh, we didn't do an observation. Looked rather globby after just the 2 minutes that we gave it. Faint glow around a bright core. 7217. And the next object is 7296. We were supposed to start it at 11:30. We're just 2 minutes off now. 7296. It's an open cluster in Lacerta, Lacerta, 7296. An open cluster in Lacerta. Wow, look how many stars there are here. Wow. That's so many. 7296. And look how there's one right above it. 7296. 96. $72.96. Azray. Doug, have you tried to use the zoom button in the live stack histogram? No. I think that just zooms in on the live stack. It doesn't zoom in on the picture though. I like that you read everyone's comments, Doug, but my goal is to get to the point you can only read 1 or 2 comments because there will be too many for you to keep up. That's great, Don. That night that we tried to see the meteor storm, that's the way it was. Stu, we're just like Australians, but smarter, better looking, and better at football. And you Kiwis played more rugby. New Zealand has dark skies. Jen laughed at Stu's point. Jen, my best friend in Sydney is moving to Brisbane. Quite the move for him, I bet. 7296 is on page 274. $72.96. It's a very small but rather obvious and pretty open cluster. I see it. May be difficult under light polluted skies. Small but moderately condensed is 2 arc minutes haze that swells to 3 arc minutes with averted vision. With direct vision, the cluster appears mottled. With averted vision, it looks like a cape of faint stars blowing in a wind. Yeah, I can see it. The cluster is most beautiful at 72 power. A splash of dim suns that flows southeastward from a 9.5 magnitude sun. Contains 20 members of 10th magnitude. So I trust you guys can see it right here. Kind of looks like a man. Look, here's one. Here's his right leg. Here's his left leg. Here's his left arm. There's his right arm. Here's his abdomen. And there is his robot head, eyes. It's a robot. Can you see it? Right leg, right arm, left arm, robot abdomen, robot scary amber orange head. The robot cluster. The robot cluster. Starry Night Pro simulation curriculum. When are you going to fix this glitch? With deep respect, this is bothersome. This is the 3rd time. You see, I try to start it. The only way I know how is to go back and add a new one. The robot cluster has around 30 members, 10th mag and less. 7296. It's beautiful. My goodness! Every one of those is a star like our sun. You know, you can still see the robot guy. It's the robot cluster. Take me to your leader. I've lost my power supply. Look at all those stars. Wow. 7296. Ashley, I live in a city, never get to see the sky like this. That's why I love watching your live stream. You are so kind, Ashley. Thank you for that encouragement. Me too. I don't get to see stars here in Louisville either. They're light polluted until we get our scope going. Asray, no, it is for the histogram. Yeah, that's what I meant. It's a zoom of the histogram. I did try it once. It didn't seem to help me much. Don, so many background stars. Asray, it helps you see the color curves better. Oh, okay. Well, we'll try it in a minute. Jen, you'll probably laugh at my question, but when we are viewing the galaxy or such in a name, what is that? Like, what is Lacerta? It's the constellation name. Stu, it's 3:35 p.m. here and raining again. No dark skies for us. Rats. Don saw the guy. Lacerta, sounds like a city in New Mexico. Ashley, yes, he's dancing. Jen, yes, more than a stick man. I used to draw like that. Lacerta is one of the 88 modern constellations defined by the International Astronomical Union. Its name is Latin for lizard. Don, the robot roamed the new Lost in Space danger, Will Robinson. Yep, I agree. Jen, a constellation. Wow, I have to make a study of constellations. I only know a handful. Thank you, Stu. Don, from Stu, or a galaxy. Jen, I'm so dizzy. My head is... Stu, so Virgo, Ophiuchus, Pegasus are the constellations. Jen, that's beautiful. It is a beautiful night sky, isn't it? Gorgeous. All right, here we go. Back to next target. We're going to go, we move 7296. 7296. From the working list, we're going to add 7296 to the observed list. And Corin, good to have you from London. 7296. After is 7380. 7380. Whoops. 7380. Oh, this is going to be beautiful. This is a nebula, I think. It is a diffuse nebula, and it's in Cepheus. (7380). A diffuse nebula in Cepheus. Looks challenging. 7380. Let's plate solve just in case. Hi, Corin. Got to be 2,000 stars in that field. I agree, Don. There had to be 2,000. Jen, only 2,000? Oh, that's kind of you, Don, to ask Corin to give you a thumbs up. Yeah, if you like content like this, it does help if you do thumbs up. Opposite side of the world. It's 3:40 a.m. for you. Good morning. Wow, is it really 3:40 a.m. in London? That's crazy. We were off 1/4 degree, so we are doing a correction here. We'll let it settle down. We see no diffuse nebula yet, do we? All right, let's start the live stack. And read about 7380, which is on page 278. NGC 7380, Caroline Herschel discovered it in 1787. It's a fine assortment of coarsely scattered stars 2 degrees east of the famous variable and the double star delta Cepheid. It's easy to see in 750 binoculars in small condensed glow of uniform brightness. And through the smallest of telescopes, it appears as a delicate glow with a central condensation and faint asymmetries. In telescopes, the cluster is veiled in soft nebulosity. Wow, it's a very pretty sight. It displays a triangular-shaped body of stars, yep, surrounded by nebulosity, both bright and dark. So there's a dark nebula here too. It's also a rich Milky Way field. the glow and intensity of the nebula differs ever so slightly from that of the neighboring patches of Milky Way, something best appreciated in a dark sky. At a glance, about 50 stars pop into view. At 72 power, the main body of the cluster again has a triangular shape. There's also a main arc of 3 bright stars. The central one is a fine double with 7.7 and an 8.6. The cluster contains about 125 stars of 10th magnitude and fainter, so it's a delight to see. 7380. So did you guys catch all that? Here's the arc of stars, and there's the double in the middle. Double star. And then here is the apron of nebulosity and a dark nebula flowing through it, like a river. There's a river of stars here too, in a straight line. Don says, probably many more, but I count too slowly. It's fun, educational. Doug is relaxed and it's great to listen to. Who wouldn't like that? Don, you're very kind. That looks like the red glow on an opal I'm carving. Yes. Jen, that's funny, Don. I love to chuckle. I was asking a serious question. I learned from all of you. Don, can you zoom in on that double? Yeah. So we're at 154% of our opticals, so we're beyond the optical, but there is the limit of the digital zoom before it turns to pixelation. So there's the double star. Now look at all this nebulosity. Let's do a color balance just in case. And then let's move our black level until the sky goes black. Then let's give ourselves just a little more mid power, and that'll brighten up that nebula. This red part is all hydrogen alpha gases that are being excited, ionized by probably this double star and this star, and it's causing those gases to light up, like we've said before, like a neon light. It's a beautiful cluster and nebula combination, isn't it? So here's the nebula, triangular in shape, as Omira pointed out. This is beautiful. I'm going to do a quick little screen grab of this from like, what? Something like here. Boy, that nebulosity is starting to approach quite far. And this is desktop sharp cap captures. This is NGC 7380 after 4 minutes and 13 subframes. On 2022-08-24. That's a neat little picture. We'll also save exactly as seen. The Wizard Nebula. Is this the Wizard Nebula? How about that? The Wizard simulation curriculum. We need an update to get rid of that glitch. The Wizard Nebula, according to ASRAE, is centered behind NGC 7380 cluster. So it's both a cluster and a nebula. Both dark and diffuse. So there are two nebulae here, a dark one and a diffuse. So here's the dark, like a little river that parallels these stars. And here's the diffuse hydrogen alpha. That's just beautiful. Look at that. There's a dark nebula here too. Look at the way it's blotting out those stars behind it. Let's see if Starry Night Pro mentions that. Yeah, LDN 1200. LDN stands for, I forget what the L is. It's the guy's name. Like Leibniz Dark Nebula Catalog, and this is Dark Nebula 1200. It looks like a river of darkness, doesn't it? We don't really know what dark nebulae are made of. It just must be some kind of dark dust and gas, right, that's covering it up. But look how it's suddenly like blotting out this amazing star field. LDN 1200. It's amazing. Just can't get enough of this. NGC 7296. Jen asks, so how long do you think this has been out there? Don says, lots of golden stars in there too. Thanks, Doug. You're very kind, Don. Stu says, millions of years, Jen. Azray, the red is starting to show up. Jen, and it will never burn out? Don, excellent balancing now. Really brings out the nebulosity. Stu, the more we watch, the redder it gets, but we must move on. One to come back to for sure. You're right, Stu. Don, all things burn out. The universe will end darkly. Jen, wonder when? Don, that's the question. Stu, it might have burned out already. We just haven't seen that light yet. Jen, amazing. Stu, blows my mind. Falling behind, Doug. I know, rats. Don, too true, Stu. Sorry about the alliteration. Jen, I'm confused now. How can it be burned out while we're viewing it? Because light's traveling at 186,000 miles per second, but this nebula is located so far away. I don't know if Starry Night Pro tells us how far away it is. It doesn't. NGC 7380. NGC 7380. 8.5 thousand light years, plus or minus a third of a light year. So 8,500 light years. So at the speed of light, traveling at the speed of light, this nebula sent out its light 8,500 years ago. And that light has been traveling in those photons and waves. It's been traveling toward us for 8,500 years. Tonight, it hit the mirror on the back of our RASA telescope, and those photons stopped. I always feel guilty about this. I've told you guys before, I feel like I've stopped a voyage that could have gone on for a lot longer, and I hogged an entire 11 inches full of photons tonight, and we here in our group, we hogged those and they stopped. So for 8,500 years it's been traveling. What that means is maybe 8,400 years ago, something came by and blew this up, and we haven't seen it yet because it'll be 100 years before that light gets to us. Even though light's traveling at 186,000 miles per second, we're watching something that took so long to get here that we're watching the past as we watch this. Isn't that fantastic? Jen says, I'm definitely going to have to revisit the light year thing. Yeah, and then Azray says 8,000 to 9,000 light years. Okay, let's save one more picture of this, and then we got to move on, don't we? 7296. Oh, we already removed it. 7380, sorry. Does that mean that we had the wrong name up there? 7380? It does. Rats! So that name was going to be under 7296. I'm going to make a note of this and change that. Change NGC 7296 to 7380. That was misnamed because I had forgotten to change the sharp cap name. So we're on next target there. 7380. Herschel pointed observed. Okay, 7380. The next one was supposed to have been 7448 at 1140. Oops. We're 15 minutes behind. 7448. It's a spiral galaxy in Pegasus. .448. A spiral galaxy in Pegasus, the winged horse. So we're looking southeast. That's the building we're in, by the way. That's the building I'm sitting in. It's right over our building. 7448. Okay, 7448. Do we do a plate solve? Anybody see a galaxy there? I don't. We better plate solve. Make sure we're tuned in. 5.879 quadrillion million miles to the light year, Jen. Jen says, whoa, Don. So 46.5 quintillion miles away, but you can bet there's a Starbucks there. That's funny. We were off half a degree. I'm glad we plate solved. Our sun is 7 light minutes away, Stu says. Jen, that makes sense. Doug, but you capturing it tonight stopped it, like for good? I know, for good. Sorry, I'm the overly inquisitive English major. Yeah, once those photons hit our mirror, then they're dead. They were sucked up by our telescope. They were sent up into the imaging of our camera, and that was the end of the story for them, sadly. So nobody will ever see those again, but there are plenty more coming. Don says the scale of just our galaxy is astounding, but still small compared to the entire universe. Jen, glad I don't drink coffee, Don. Jen, funny. Don, he stopped the journey of those specific photons, Jim, but that nebula emits trillions and trillions per second in every direction. Exactly, Don. Stu, if Doug's telescope didn't stop the light, the Earth would have. Seems romanticism runs deep in the astronomer's veins. You're right, the Earth would have. I don't feel so bad now, Stu. Jen, really? We kind of killed him? Oh my. You guys are great. You're really getting into this. I love it. Oh, I can see it right there in the middle. Okay, let's do a color balance and move this dark sky over a little more so we can see a little more of the maybe right there. Now let's zoom in on this galaxy. Still pretty early. It still looks pretty mottled. 60 seconds. It's not long enough for this galaxy. 7448. this galaxy. Okay, if you're watching this simulation curriculum, will you please do an update and get rid of that glitch, please? This galaxy. Oh my goodness. This galaxy is tiny and faint. 7448 on 280. A very small and dim, that's his opening sentence, very small and dim galaxy, less than 1.5 degrees northwest of 2.5 magnitude Alpha Pegasi. Seeing it in a small telescope requires a dark sky and moderate magnification. It's only 1 arc minute wide. It's roughly 12th magnitude star, 2 arc minutes west of an 11th magnitude star. At 72 power, the galaxy's slightly elliptical form is apparent, being oriented north-northwest to south-south. Yeah. At 101 power, the galaxy remains condensed and apparent with small, slightly elliptical core. So after 3 minutes, we began to see that it was a spiral, didn't we? Still, after 3 minutes, we could already detect the spiral structure. Now, granted, it's got a lot of mottling. Wonder how far away this galaxy is. This looks far away. (7448). GC 7448. 79 million light years. Plus or minus 22 million. 79.5 million light years. Oh my goodness. 79.5 million light years. 60,000 light years across. Can you believe that William Herschel discovered this in 1784? 79 million light years. Oh my goodness. We're looking at something 80 million light years away. This light has the apparent age. It's been traveling 80 million years by apparent age. That's just beyond belief. 7448. Stu, not the end of the story, because new light was created by the computer imaging those photons. Good point, Stu. Don, you make astrophotography sound so brutal, Doug. Yeah. Nice point, Stu. Don, a redirection, but not immortalization. They'd have existed longer as free-range photons. Jen, oh, now I understand. So capturing a photo is one that will never be seen again unless you look online. Cool. Don, longer, yes. Ashley, is that a baby galaxy? How old do you think it is? Stu, laugh out loud, free-range photons. Jen, I am Stu, Don. Tiny and faint relative to the position of the observer, yes. Billions of years, Ashley. Crazy to think there could be an Earth in there. Jen, me too, Don. Laugh out loud, Stu. Mine should have said, I can't do the math. Space-time does a number on my brain, Stu says. Don, parallels on that distance is tough to get. Redshift are the predominant way they measure galaxy distance. Dinosaurs were just getting started when this light left that galaxy. This really makes my mind think. You're right, Jen. Indeed it does. Well, that's pretty cool. 7448. Let's wrap it up. 7448. 7448. Gone from the working list. Save it. 7448. Added to the observed list. Next object, 7510. Well, hopefully we'll get to something that wasn't as interesting. This is an open cluster, and it's in Cepheid. An open cluster in Cepheid. See, what I'd like to do is acquire muscle memory, so these things just happen without thinking about them. Oh yeah, there we go. Look, it's like a seashell. Snapshot. It's a cool open cluster. Shaped like a seashell. 7510 is on page 278. Moderately small. Displays a very bright linear core. Halo of dim suns materializes. A dozen bright suns. Very appealing asterism. It looks like a fish hook. Okay. I guess upside down. Or a mouse with a thin tail curled up on its back. Oh, so the fish hook is out here, he's saying. The fish hook is out here, and this is the mouse with the tail curled up. The cluster must be a glorious sight in larger telescopes because this tiny grouping actually contains 75 members of 10th magnitude. Stephen James O'Meara. By God's grace, we have a large telescope. So we're going to say it is fun, and we're going to move on. 7510. 7510. 7510. You guys are saying I should go to the computer and stop phone typing. This is better than any meditation I've done. Seriously. My thumbs are too fat for a keyboard. Never mind a phone. Gone unless you take an image of it. 11,400 light years. I'll save you this earth. Thanks, Don. Mike. A mini Pleiades, right? Jen, Azray, I have to finish signing up for AstroBin, but wanted to make sure I have the correct site. It's like really cheap, correct? Yes. Don, I agree, Jen. I love the choice of music. Doug really nailed it. Boy, that's awesome, you guys, saying that. It adds depth, Jen says. Azray, yes, Jen, not too much. I think I spent $60 or so on mine, like for AstroBin. Dark Meta, glad to have you aboard. Let us know where you're from, Dark Meta, if you don't mind. next is 7606. 7606. This is a galaxy. And it's a spiral galaxy in Aquarius. Aquarius! Aquarius! 7606. 7606. A spiral galaxy in Aquarius! Aquarius! Small. 7606. Anybody see it? We're going to have to play it solve. I think I might see it right there. I bet that's it. Let's be sure. Ashley, do you do this live every night? Well, we try to do it at least once a week on a night with clear skies. But I'll admit, I've been sort of driven lately with this Herschel list because I knew that some of these objects were disappearing and we really needed to catch them before they did, 0.18 degrees off. So I have been live streaming more often the last week or so just to catch them that we were missing in June and July. But now we've done that. We actually now tonight, we're actually ahead of the game, and these objects we're looking at now are actually they're actually to be observed in September supposedly. So we're like way ahead. Okay, let's go ahead and start imaging, and we'll sort this out and figure out why we weren't seeing the spiral galaxy. Dane says, great job, Doug, much love. Thank you, Dane, for the encouragement. Please, Don says, please click thumbs up if you've not yet done so. That helps get in everybody else's radar. It helps it get in their heads-up display of their windshield. Thank you, Don, for remembering that. More people get this stream as a suggestion in their feed. Jen, okay, I'll find your work over there, Azray. Azray, my subscription is for a year and I can upload unlimited photos on it. Jen, I know that constellation. Aquarius! Don, about 100 million light years from Earth, Don, and 165,000 light years across. So you're talking about this NGC 7606. Oh, right there it is. So let's do a color balance, and then let's pull the black levels over to darken the sky a little to about right there. And then let's zoom in on NGC 7606. Boy, it's how far away? It's 165,000 light years across, so 1.5 times, almost 2 times as big as the Milky Way. 100 million light years! That's crazy! 100 million light years away! I can't deal with that. And we're just going to snap a picture of it like nobody's business and push on. But wow, that's far. Don told us this was 165,000 light years across and 100 million light years away. Yikes. Wow. 7606. That's just so far. 7606. North Carolina by the ocean. Dark matter, thanks for letting us know where you are. 7606 is now added to Herschel 400 observed. Next is 7686. 7686. This is an open cluster in Andromeda. 7686. An open cluster in Andromeda. Oh yeah, it's a pretty good size. It appears. 7686. You know, I think I'll get muscle memory someday, but boy, it feels like I'm still learning. 7686, right? Yeah. 7686. Yeah, right there it is. So we're just going to snapshot this and read it quickly. 7686. It's on page 308. Large and bright open cluster, easily seen in binoculars. A scattered splash of suns tickling a central double star. Oh, that's cool. Has a dimmer companion to the south-southeast, forming a clean central equilateral triangle. What? Oh, I see. Do I? I think that's it. Or this. It's not quite equilateral. He was a little bit off on his equilateralisms. No offense, Stephen James O'Meara. Field is filled with a diffuse asymmetrical light that transforms into tiny stars that jump with averted vision. At 72 power, it's a distinctly V shape, with faint outliers rounding out the cluster's edges, but mostly north and west. Though large, the cluster only has 80 true members, 7th magnitude and fainter. V-shaped. I guess. Maybe because of these stars? Anyway, pretty cool. NGC 7786. 7786. Look at that. It doesn't find it. 7686, sorry. 7686. Oops. 7686. Snapshot this again. Oh wow, you guys have been busy. Thanks, Jen. No space in the title name. Azray Astrophotography. Cool. I'll remind you to return the Wizard Nebula next month then. Nice, Stu. Outer Banks, Dark Meta. Dane, that's a pretty disk. Jen, great. I wrote that down. Dark Meta. Jen, is the Outer Banks an area near Wrightsville? Jen, that's groovy. Dawn, gonna need more than one rest stop on that trip. Jen, not too far. I know Wrightsville. Was thinking of relocating the Wilmington area sometime. Stu, and how many individual stars in that one small galaxy, and how many billions of galaxies are there finding now? Mind blown away again, Stu says. Jen, and again, why did Doug say he wanted to get through these? Because he knew that they weren't going to be there? Dark Meta, I wouldn't go to Wilmington if I were you. It's cursed. Becoming like San Francisco. I've never experienced such a toxic place. Ashley is mind blown. Meaning maybe we couldn't locate down the line. Jen, what he meant was that they're only visible in our night sky during the summer. Right. That's exactly right, Mike. Thanks for handling that question. Ashley, Jim, probably because stars do die. Mike, by the fall they will be setting too early to be seen. Right, Mike? Until next summer when they come back around, dark matter, it's terrible. Jen, oh, Jerry, I see I learned something new again. Thank you, Don. About 900 light years. Jen, I meant Mike, sorry. Mike, the sky does rotate with the seasons, so certain constellations are only visible during certain seasons and disappear until that season next year. Dark matter, I'm a super optimistic person. I try to be positive. You guys were busy. Okay, after 7686 is 7723. 7723. It's a spiral galaxy. And it's located in Aquarius. 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 This is the dawning of the age of Aquarius. '7723. 7723. A spiral galaxy in Aquarius. Aquarius. Looks small. 7723. The night sky is breathtaking over the ocean. It really causes you to feel so small against such a grand scale, and just you and the forces of nature in the moment. Don, I often feel small, and then I look in the mirror. Stu, yes, dark matter, the open ocean, away from light and land, so much horizon. Jen, true dark matter, so the Wilmington area is no good. Emerald, what are your thoughts about flat earthers, seeing what we are seeing? You know, I just wonder how I could live with myself if I claim to be a flat earther, because Don, 28 likes, 24 watching. That's good. Woohoo! Don, thanks so much for reminding people to click thumbs up. Azray, that light has been on quite a journey. Mike, do any other constellations have so many? I think you're still in typing that, Mike. This is 90 million light years away. So many songs. I don't think so. Hey, I see it there in the middle. Okay, so 7723. Let's do our color balance. Let's bring the darks over and try to darken up that sky a bit. Man, this galaxy is far away. Let's see, 20 seconds at 200. Make sure I have the right flat frame there. And those are not the right darks. Let's see. Desktop. Sharp cap captures. Darks. 2600. At 20 seconds. Gain 200. Dark 15 frames. 2021. Wow, I need to shoot new darks. Okay. Sorry, I had to. These calibration frames help make the image sharper, and when that image first came up, I could tell by the image that it wasn't the right set of flats and darks, and I don't know why they weren't correct, but anyway, I'll shoot new flats and darks and make sure those get matched up correctly. Anyway, here's this galaxy, 7723, and somebody told us 90 million light years away. Don, that's so kind of you. Content like this deserves far more views than a lot of stuff I see on the TikTok and YouTube shorts. Science is my only solace from this world, Dark Meta says. Is a song about the constellation? Yes, it's about, from an astrology point of view, so it's not really astronomy based, but Aquarius is in the zodiac, and when the planets are lined up in Aquarius, astrologers believe that something special happens. No, the boat, but the boat is named for the constellation. John Denver wrote a song about that. So kinda, that's the one. Dark Meta. Imagine we will have James Webb devices on our desks one day, like Google Earth, and think back. That's wild. Star Rider, Don, all that will be accessible from the link in your head. Digital telepathy. That's really bright star on top. Wow, you're right, Jen. Good catch. Maybe there's no answer, we'll still search. Jen, that's the only social media I do. Oh, that's awesome, Jen. Thanks for taking part. Dark Meta, I want to see it all. Let's see what 7723, page 285. Way back over to 285. We're jumping around, aren't we? 285. It's very small, very dim in Aquarius. It's near to another galaxy, 7727. So I have to check that out in a second. Under a dark sky, it's amorphous 3 arc-minute wide oval disk, oriented northeast to southwest, that hovers just above the background sky. Its intensity increases with averted vision and time. You can just tell Stephen James O'Meara didn't use EAA. It's better seen at 72 power, which shows the oval disk getting gradually brighter toward the middle to a fuzzy nucleus. You know, at 5 minutes, we can see some spiral structure starting to form up. And we see a very bright core. So I'm going to say that over here in observation. At 5 minutes. At 5, if you're just joining us, if you wonder why do I growl at the planetarium software, it's because there's a glitch in it. And I wonder if simulation curriculum is hearing me. I've reported it several times. At 5, because it's so bothersome. It only lets you type 2 or 3 letters sometimes. At 5 minutes, and what you have to do is just delete that log entry and then start another one. 5. This is, I think, the worst it's ever been. Oh, my goodness. There we go. This is the worst it's ever been. It's haunted. At 5. I've got to show them this video snippet at simulation. At 5. Okay, we're just going to have to stop. So simulation curriculum, if you guys watch this, please would you repair this glitch? We paid so much for this program. Anyway, there's 7723. 100 million light years away? That's so wild. Next target. 7723. 7723. Oh, it's gone. Okay, and then here we go to add it to the Herschel fire observed. 7727. 7727. Slew to it. Center on it. This is a spiral galaxy in Aquarius, and it's 7727. Oh, this is the one that Omir just said was very close to it. So 7723 is down here. 7727 is there. By the way, 7724 is here. So we can actually see 3 galaxies, I think, in this view. Let's go back out to auto and (7727). Yeah. Look at that little satellite trail. Little satellite moving across the screen. Sometimes in Starry Night Pro, the satellite will be here. You can see which one it was, but I don't have every satellite turned on. Whoops, sorry. 7727. Let's see. Don Small, huh? Jen, Doug, the music really makes it so much more amazing. Jen, thank you so much for encouraging. Stu, Darkman, I think you'd enjoy The Departure by Neil Asher. Don, the photo of this in Wiki is incredible. We'll have to go back and see that, Don. Stu, speaking of tech in your head and seeing it all, Jen, Stu, no reindeer constellation night? Do not have wireless in my brain, thank you. The Departure, like I can... Jen, looks like mushroom caps where my eyes are strained. Don, no way yet. Stu, Dark Meta, it's corny sci-fi. Dark Meta, how can we... Boy, that's deep stuff. All right, there goes another Starlink satellite or something. I wonder if the... Looks like our... Look at that. Those Starlinks, I guess. Pretty good matching there. We'll move this over just a little bit. bring up a little more sky glow, but and then zoom in. Yeah, here are three galaxies. Let's see if we're close enough for deep sky image annotation. Yeah, 7724 is here at the upper left. This is 7727 here and 7723 there. So this is the one we're observing now, 7727. Okay, so I'm going to turn those back off just so they don't. 7723 looks elliptical at this point, but it's supposed to be spiral. Almost seemed elliptical early on. 7727, which is on page 286. Moderately bright but very small, reasonably obvious, tight core with dim asymmetrical extensions to the northeast and southwest. Stellar pip surrounded by a disheveled oval of light. That's more like it. That's what we're seeing. The extensions in a small telescope make it appear slightly lens-shaped, as if a solid disk were stretching out. But as the accompanying photograph shows, the bright inner disk is warped and in much turmoil. It has a faint sweeping arm, which may be seen in much larger instruments. Cortex power wells, so don't be afraid to explore this intriguing galaxy with more power at a later date. How about that? So at 3 minutes, maybe we're starting to see this arm strewn out here. Quite possibly, if we use our imagination. Unfortunately, we better shove on, huh? So this is, we're going to capture, save as seen, and switch to next target. And get rid of 7727 from the working list. Boy, something's happened here. Observing list. Caldwell working. Edit. 7727. It's not in there. Observed. Well, in any event, let's push on. 7789. 7789. Center and show info. This is Caroline's Rose, an open cluster in Cassiopeia, 2 S's, Cassiopeia, 7789, open cluster, 7789, an open cluster in Cassiopeia, Caroline's Rose. Oh, look at that. That's a beautiful cluster. 7789. I think it's here in our, oh yeah, I think it's right there. Let's go ahead and plate solve just to center it so we see the whole thing. 7789. What are you guys saying down here? Don's talking about a big star, the mass of the sun, can collapse on itself and make a black hole. 3 galaxies in that view, right? Azray, thanks again for the live stream, Doug. I have to go for now. Good night to everyone. Good to have you aboard, Azray. Whoa, what are in those black holes? Good night, Ray. No one knows. Maybe Starbucks. Stu, hole is the wrong word. It's very misleading. Of course, Starbucks. Jen, good night, Azray. Thanks for... Don, no dark. There's Safari. Jen, everything. Correction. Just watch Interstellar. Stu, Event Horizon. I'll watch it 8,000 light years away. Thanks, Don. Caroline's Rose you're talking about, I trust. Let's just live stack this just briefly. Doesn't look like we're going to need a lot for this. But let's read about Caroline's Rose. It's 7789 on page 288. Caroline Herschel discovered 7789 in October 1783. This beautiful open cluster lies just 3 degrees southwest of Beta Cassiopeia and is at the limit of unaided vision. The cluster is a magnificent spectacle in binoculars, being nearly... My goodness, that's beautiful. Being nearly as large as a full moon and just as round. In fact, through binoculars, the cluster looks like a tailless comet crossing the rich field stars of the northern Milky Way. With any scrutiny, the cluster sparkles as the light of dim suns pop in and out of view in your peripheral vision. Through a telescope, it is one of the finest and richest open clusters in the sky. It's at its best in 23 power. With imagination, the central core of suns appears three-dimensional. Okay, like a fistful of diamond dust. Whoa. At 72 power, the number of visible suns increases to about 150. The view is splendid in larger scopes. The cluster sports some 580 stars, the brightest of which shine a magnitude of 10, the faintest hover around 18th magnitude. 580 members. Wow. So let's color balance this. And then let's pull this dark, the black level, over to about right there. That's just a matter of taste. And then let's pull the mids in just a little and zoom in on this. Maybe it looks better back there because it's so big. Wow. It's beautiful. I think that's enough to appreciate it. But Caroline, thank you for discovering this for us. Yep, that's the rose. Right. A masked face in the center. What a magnificent cluster. Wow, look at that beauty, Jen says. Don, yeah, 30,000 light years is closer. But still. NGC 7789, NGC 7789. Why are we not seeing these? NGC 7789. What's going on? We're in the Caldwell? Oh, we're in Caldwell working. No wonder we weren't seeing them. H400 working. 7789. Still with the H400 working. That's weird. NGC 7789. Well, I can't explain why that's not there. Observe, but it's not. It's obviously not. So. Okay, so we're ready for the next, which is 7790, next to the last object. 7790. And this is an open cluster in Cassiopeia. 7790. I think that Caroline's Rose was probably the prettiest cluster we've seen, right, gang? 7790. So it's not in the same field as Caroline's Rose. 7790. Anybody see it? $20 million trips to the moon is 1 light year. 7790, 289. It's a very small and dim open cluster, about 2.5 degrees northwest of Beta Cassiopeia. 2 dim clusters lie nearby. Extremely small and sideways V of starlight. Extremely tight, a dozen suns are splashed across 5 arc minutes. Difficult to discern the other members of the cluster against the rich Milky Way background. Well populated though, 134 members of 10th magnitude. 7790. Oh, I think we see it. Yeah, he described it as a, remember he described it as a sideways V of starlight. Larry Fraley, good to have you aboard. Larry's saying, when you think about all these distances, think about the one who created it. Jen's pondering that. 13 billion light years away with the James Webb. Jen says, right, Larry. You know, oh look, my goodness, this is beautiful. The other thing that I wonder about these distances sometimes is assuming that I mean, and I do assume that God created the universe. Could he have created the universe in motion when he started things out so that these distances are apparent distances and apparent travel of photons? He could have created the light in progress, just like you see a football game when it runs over and your favorite TV show is in progress. It's kind of weird, isn't it, to think about that he could have created the universe in progress. So this is NGC 7788 here. 7790 is here to the right, using deep sky annotation. So this is 7790 right here. This makes a beautiful picture to see all of these in one field, doesn't it? What a beautiful picture, right? NGC 2 minutes is all. 6 subframes. 2022-08-25. Beautiful. Boy, this is just a beautiful patch of sky, isn't it? Let's just look at that for a minute. How beautiful that is. Jen says, I believe God created it, Doug. I do too, Jen. I'm with you. Don, it's just easier to believe this is just painting on a gloss dome. Mike Cherry, you're preaching the choir, Jen. Principles, see, that's poetic for certain, Stu. Don, it's diamonds on the sole of God's Birkenstocks. Nice. Stu, that's very old, not original at all. It's just beautiful, isn't it? Okay. Save image as seen. All right, gang. This next object is the 400th object in the Herschel 400 list. However, I want to make it clear that we haven't finished all 400 yet. We just had to skip to the end because they're the ones that are visible now. Well, I'm about really discouraged about this. Observing log thing in Starry Night Pro is really a bummer, isn't it? 7814. 7814. Maybe upon restarting, maybe we're just taxing it too much. Maybe it'll straighten out when I restart Starry Night Pro later. This is a spiral galaxy and Pegasus. 7814. A spiral galaxy in Pegasus. Number 400 on the Herschel list. Okay, right there in the center. Jen, we're done? Don, very good. Jen, okay, whew. Don, it was a good candidate for 400. Why did you stop at 400? It's close, only 40 million light years. Okay, so I got to tell you, but let's get this started as soon as it plate solves. I got to tell you the way this works. Herschel discovered about 2,500 galaxies, they figure. We're off 0.64 degrees. Herschel discovered about 2,500 galaxies with Caroline's help. There are a ton, obviously. They do overlap some with the Messier list, and they do overlap some with the Caldwell list. So in the late 90s, an astronomy club down in St. Augustine, Florida, they said, after you finish looking at all the Messier list and looking at all the Caldwell list, it would be nice to have another list to go to, especially because so many of Herschel's objects are cool. They're just harder. They're just more challenging. So they began curating from the 2,500 deep space objects and narrowed it down to, like, I forget, 600 or so. And it took them a year or 2 years to curate it down to 400. When they got to 400, they said, that's it. We can't go lower than 400 in this curated list of Herschel's best objects. So they released it in Sky and Telescope magazine, and it caught on immediately. People started wanting to go look at all the Herschel 400, the 400 objects on the Herschel 400 list. And they are, as we've said, they're visible during special times of the year, depending on what season it is. And the way it worked is we started the Herschel list about mid-year. So by the time we finish tonight, I think we have like 220 to go or something like that. We're not quite halfway done. But we won't be able to finish them until another month or two rolls around. as soon as we can, we'll do more, and they'll be starting with the early ones. So in other words, Herschel number 1, 2, 3, 4, and so on. But we've seen the ones that are numbered at the end of the list, based on the way they were numbered by the St. Augustine Astronomy Club. So that's the way this worked. I see the spiral right there in the middle. So let's zoom in a little. This is at 100% of our telescope's optical. Let's do I should say our camera's optical, shouldn't I? Let's pull this black level down to about right there. And that'll make the galaxy a little nicer to give us a little sky glow. You can almost see already the dust lane of the galaxy. We're viewing it edge on, obviously, because you can see the dust lane like it resembles, what is it, Messier, is it 104, the sombrero maybe? That's what this reminds us of, that dust lane across that galaxy, whatever that is. I think it's 104, the sombrero. So that's beautiful. All right, we're going to save a scene. That's NGC 7814. So we're going to switch this back to next target. And we're going to look for 7814. That's weird. We're in the Herschel working. NGC 7814. This one's not there either. Weird. Add it to the observing list. H400 observed. At least we can add it there. And at this point, we have finished our observing list for tonight, and we have 4 minutes left. Let me see what you guys had to say. This close of this one is great too. Edge on a dark central lane dividing the halves. Yeah, great ride. Thanks, Etienne. Thanks for being with us. So what will we view when we're done here? I like to look at the future. Thank you, Doug, for explaining that to me. Don, up to 33 likes. Smash that thumbs up if you haven't yet. That's so nice of you, Don. Yeah, Jen, we'll be back on the Herschel 400, and there are tons of Caldwell objects we haven't seen yet also, so we'll go back on those. And now Don says Saturn. Exactly. That's what Don's been waiting for. So we're going to go up here and we're going to say Saturn. Slew to Saturn. It's at 36 degrees up, Don. You'll be happy to know. Now keep in mind, this is a RASA, so it's not a long focal length. It's not a long focal length scope. So for instance, if you look at the field of view of the RASA, Saturn is right there in the middle of the field of view. It's a short focal length scope. It's something like 640 focal millimeters, 640, I think, something like that. Boy, right there it is, right? Wow. Spot on. Okay, so what we're seeing here are some of Saturn's moons. Quite a collection. So let's first kind of pick those apart. And what we'll do is we'll go back here and we'll zoom way in now. So for orientation, our RASA is over on its side, and that kind of messes up the angle. But look how these 4 moons are tight. So let's go back up here to, if we can get Starry Night Pro to cooperate with the program. What would be the 4 tightest, largest moons? Could be, for instance, Dione, Telesto, Mimas, and Enceladus it could be. But look, Titan is way out there, and Iapetus is way out there, and Rhea. So on one side, we should see a little zigzag, like a lightning bolt. And that's Iapetus, Rhea, Enceladus, Tethys. Iapetus, Rhea, Enceladus, Tethys, and maybe even Calypso. So let's look for that lightning bolt. So it's probably... We're seeing a lot of its moons, aren't we? So this must be the lightning bolt. Iapetus. And then there are two apparent moons there. Iapetus. Oh yeah. Iapetus, Rhea, Calypso, Enceladus, Tethys. Iapetus, Rhea, whatever those three that I said, and then these, look at these four that are very tight. Saturn has a ton of moons. I mean, it's like 86 or something. And I think we're seeing half of them tonight. Look at this mixed. Now, those are the moons. Now, let's see if we can get to see the rings. So let's zoom in a little more. And then let's cut our gain down to like 100. Let's cut our time down to like 1 second for starters. Would you believe 0.3 seconds? Would you believe 0.1 seconds? Maybe 50 milliseconds. Okay, so there we start to get separation between the planet and the ring system. But it's such a tiny vision, such a tiny target, it's not as enjoyable, is it? What does this tell us? It tells us the RASA is great for deep sky objects, observing them very fast, because it's f2.2 for Pete's sake. It's incredibly fast, like among the fastest telescopes you can buy for any amount of money. But for planetary, it's just not really a strong suit of something pleasant, is it? I mean, seeing the moons is fun, but boy, this is not a beautiful image of Saturn like you would see in a 3,000 millimeter long focal length telescope. Let's see what you guys are saying about all that. The rings, yes, but these other objects were nice to see. How many moons? Don says 82. Don says you'll only see 3 or 4. I think we're seeing more than 3 or 4. I don't think those were all stars. But the Earth has only 1 moon. Wondering why again, wondering out loud. It's because of that ring system. There are lots of moons in that ring system, Jin. Yeah, that's not the best telescope for planetary. You need f8, Don, or greater, right? So there you go. It's just a trade-off, and that's why some people have, you know, multiple scopes. For my part, I don't plan on getting multiple scopes just because the cost and a lot of other reasons. But I love this RASA because mostly I love doing the deep space stuff. But I told Don we could go look at Saturn tonight, so that's what we did. And we can bump our gain now up to like 200 and see all those moons again. There we go. So, gang, it is 1 a.m. and I promised we'd be done before now. Thank you for staying with us. Thanks to everybody. We still have 18 people on the live stream. That's amazing. We're so grateful for the chance to be able to to do this. I guess we have to thank God for making all these beautiful objects. We'll update the spreadsheet now. That's at emeraldhillskies.com under the Resources tab. And that spreadsheet tells us exactly how many of the Herschel 400 list objects we've observed. And you'll be able to see the next ones that we'll be working on as time goes on. Do keep your eye out, because if it's clear this weekend, we'll be back at it this weekend. But for now, that's it. And thanks for sticking with us. It's a little bit longer tonight because we were working on 25 Herschel list objects. You guys have been great. Thanks for sticking with us. We love you. We appreciate you. If you like content like this and you haven't subscribed, please click subscribe. Like Don says, click the thumbs up so this gets in other people's YouTube searches. And click the notification bell if you want, and that way you'll be notified when we're doing content like this. That's it from Emerald Hill Skies. Let's see, I love Saturn, but deep sky are far more plentiful. Thanks, Doug. It's very kind of you to say. Jen, I love this format of setting a goal of viewing X amount of objects, and now the music along with it. Thanks for the encouragement, Jen. You are very kind. Don says, great streams, 36 likes. Awesome. God bless. Have a great night, and we'll look forward to catching you next time on Emerald Hill Skies. Take care. Good night.